Our topic is going to be the area of a triangle. And so we know how to do area with our 1/2 base times height. But what if we only rely on the angles and the sides of the triangle, not any other information about it? So that's what we're going to do today. We're going to look at different equations and how we can handle situations where we don't necessarily know the height of a triangle. So, first thing, as I mentioned before, the normal equation for area is 1/2 base times height. And that's easy to do with a right triangle that you have your base and you have your height, and that works out nicely. What if we have an oblique triangle? And I want to make this clear that it's not going to be necessarily an isosceles or a equilateral triangle. That equation still holds, but we'd have to know that extra information. So our question is, how can we use just side lengths to find area and not have to rely on knowing h? So important thing here is that our h is across from our a. So it makes it opposite. And we know the b, which is our hypotenuse. So sine of a is h over b. If we go ahead and solve this equation for h, b sine of a equals h. So back to our equation here. Actually, it's going to be we'll have to modify things a little bit. That our area still has the 1/2. Now our base, we don't call it b. That's going to be our c side here. And then our h is going to be our b. Let me make that sign look like the word sine of a. So we have a new equation here that can be used to find area based only on side lengths and angle measures. And notice what we have. It is a side angle side setup where this works. And now we could have done this again, that notice that our h is also across from our b. So we could do a similar thing of sine of b equals h over a. Multiplying over our a sine of b is going to be equal to h. So we could also have 1/2 a times c sine of b. And if we want to do it also, we could do 1/2 a times b sine of c. So all three of these equations rely on a side angle side setup and can give you the area of a triangle with only using the side lengths and angle measures. So let's try one of these. Let's say that the measure of angle A is 50 degrees, side B is 5, and side C is 8. So this is a side angle side setup. So therefore our area is going to be 1/2 B times C times sine of A. By the way, notice on all of these that all these equations up here that this one has an A, a B, and a C. An A, a B, and a C, an A, a B, and a C. So something is represented from each of our letters there. All right, so plugging things in, 1/2 times 5 times 8 times sine of 50. Make sure again that you are in degree mode. And it turns out that our area is roughly 15.32088888624 in whatever units we have squared. So fairly straightforward as long as you have the information you need. However, if you're not given all the information you need, you can then use potentially the law of sines to find other angles or side measures that you need to then use this formula. So this can be used in conjunction with law of sines. Next up, it's something called Heron's formula. All right, in your area here, and let me make that a bit nicer lettering, is the square root of s times s minus a times s minus b times s minus c. So since we're using a, b, and c, this is going to be a side, side, side situation. Of course, what is this s value that we're given? The s is a plus b plus c all divided by 2. So since a plus b plus c is the perimeter, distance around the outside of the triangle, when we divide it by 2, it's the semi-perimeter. So that's why we use s. All right, so let's try an example of this. Let's say side A is 10, side B is 8, and side C is 12. So finding our S, it's going to be 10 plus 8 plus 12 all over 2. Adding up top, we get 30. 30 over 2 is 15. All right. So our area is going to be the square root of 15, 15 minus 10, 15 minus 8, 15 minus 12. So 15 times 5 times 7 times 3. Now, there's two ways we can handle it from here. One is just multiply all of our numbers together. So that is going to give us 15 times 5 times 7, the square root of 1,575, which is roughly 39.6862696666 units squared. However, you might be asked to find the exact value, but in simplified form. So we need to break down this square root. Now, a way that we can do it fairly easily is by looking back here. Now, 15 is 5 times 3. And then we also have another 5, a 7, and a 3. So looking for our matches, 5 times 5 is 25. Square root of that would just be a 5. 3 times 3 would be 9. Square root of 9 is 3. And then our 7 stays in. So we could rewrite this also as 15 square root of 7 units squared. Let me make my 5 look a little better there. So be careful how a question asks you to solve it or how to write the answer. If it wants exact values, just simplified, do your factoring, and it can work out pretty nicely from here. If it wants a decimal approximation, then you just use a calculator. So that is our area with triangles. We have two different ways that we can do it. If we have a side angle side, then we can use our first equation with the 1/2 AB sine of C or whatever offshoot of it. If we have all the sides, we can use Heron's formula. And if we have neither of those situations, we can then use our law of sines to find the other information we need, and then we can use one of those formulas.